Alright, we're going to look at section 6.1, which is inverse functions. So we're going to review what an inverse function is and how to find an inverse function. Okay, so if a function is one-to-one, then it has an inverse. And we know a function is called one-to-one if it never takes on the same value twice. Meaning, no matter what x you put in, you're going to get a different y value for each input. Alright, the way to test if a function is one-to-one is to use the horizontal line test. So similar to the vertical line test that you use in Algebra 1 to figure out if a graph is a function, we use the horizontal line test to figure out if a function has an inverse. So a function is one-to-one if and only if no horizontal line intersects the graph more than once. And then a function has an inverse if and only if it passes the horizontal line test. Okay, then you'll have a set of notes regards to the domain and range of an inverse function. So f inverse of y is equal to x when f of x is equal to y. The domain of f inverse is equal to the range of f. And the range of f inverse is equal to the domain of f. So when you find an inverse, you switch your domain and range. Okay, and the last thing to note about the inverse is that this -1 is how you denote an inverse. It's not an exponent. Okay, it's just the way we note an inverse. So don't think of it as like f to the -1. It's not an exponent. Okay. Alright, so if I look at f of x equals x cubed, the first thing I need to know is if it's one-to-one, and if it is one-to-one, then I need to find my inverse function. So the first way to find if a function is one-to-one is to graph it and see if it passes the horizontal line test. That's one of the ways to determine if it's one-to-one. So go ahead and graph x cubed y equals x cubed.
What?
Graph y equals x cubed. I will if my calculator works. Alright, so if I look at the graph y equals x cubed, if I were to draw a horizontal line, so a flat line, through that graph, would it touch the graph in more than one spot?
No.
No. Okay, so that tells me that it is one-to-one. Okay, so yes, it's one-to-one. So then we need to find our inverse. And the way to find your inverse is to switch your x and y. So if I'm given the equation y equals x cubed, then to find my inverse, I'm going to change that to x equals y cubed, and I need to solve it for y. So how would I solve this for y? Cubed root. So I would end up with y equals the cube root of x. So that tells me f inverse of x is equal to the cube root of x. You just replace y with f inverse. Okay, so yes, it's one-to-one, so it has an inverse, and the inverse is f of x equals the cube root of x. Okay, so any questions on that one? do the same thing then for f of x equals x squared. So I'm given f of x equals x squared. I need to determine if it's 1 to 1. So to do that, you need to graph y equals x squared. Okay, so to be 1 to 1, it has to pass the horizontal line test. So if I were to draw a horizontal line through that graph at any point, so if I were to take and draw a horizontal line right through here, would that pass the horizontal line test? Would it only touch the graph once? No. Okay, so it fails the horizontal line test. So that tells me that it's not 1 to 1. And since it's not 1 to 1, then it doesn't have an inverse. There's no inverse function that works for x squared. Okay, so let's practice finding an inverse function one more time. So if I'm given the function f of x equals x cubed plus 2, and I need to find my inverse function, what do I need to do to find that inverse? That's to tell me if it's 1 to 1.
Oh, okay.
I just need to know how to find my inverse. Switch the y and x, perfect. So if y equals x cubed plus 2, then if I switch my y and x, I get x equals y cubed plus 2. So what's going to be my first step in solving that for y? The minus 2. Okay. So x minus 2 is equal to y cubed. Cubed root, okay. So y equals the cube root of x minus 2. And then what's my last step? So I need to replace the y with the inverse. Okay. So f inverse of x is equal to the cube root of x minus 2. So any questions on determining inverses or finding them? No. Okay. Next, you guys are going to work through page 393 through 16 and 23 through 28.